The Human Experience, Chapter 14 by Dr. David Carmichael. Global Warming Legacy of Human Development. This is literally a math test, and it's not being graded on a curve. It only has one correct answer, and if we don't get it right, then all of us, along with our 10,000-year-old experiment in human civilization, will fail. Bill McKibben, 2016. Several sorts of insights should be obtained from this chapter. First, you should develop a basic understanding of what global warming is and what scientists understand. To be the causes and mechanisms of the processes involved, that is what is the scientific consensus. Second, you should become familiar with the kinds of evidence that have led an overwhelming majority of scientists to reach consensus on the facts, causes, and implications of global climate change. The webpage built to accompany the film, An Inconvenient Truth, summarizes more than a dozen specific sorts of evidence for global warming and human agency in global warming. I will leave this site at the end of the video. There's also a supplemental reading that I will also leave. You should be able to discuss that evidence. Third, you should be able to recognize some of the spurious arguments used by those who deny the reality of global warming and identify the faults in such arguments, as well as the reasons some people still adhere to those ideas. Fourth, you should be able to show how global warming is part of the evolutionary trajectory of modern humans and how it relates to topics previously discussed in this book. Hopefully, you will be able to discuss what you might do in response, individually and collectively. Question answer: how is modern climate change related to past human activities? Continued population growth and the ever greater intensification of the food production technology needed to feed that population have led to agricultural dependency on fossil fuels. Beginning the onset of the industrial age and acceleration in recent years, the use of fossil fuels is now impacting the climate to which we have adapted. The scientific consensus. By now, most or all of you have at least heard of global warming. If you are like many Americans, however, you may not know much about it, and you might not even believe it's a very important issue. Nearly half the adults in this country either don't believe global warming is real, don't believe human actions are contributing to the problem, or don't believe it will have significant negative effects on our way of life. All these beliefs are scientifically indefensible. There is now an overwhelming scientific consensus that global warming is real, that human actions are making a significant contribution to warming, and that warming will have devastating consequences for all of us. If you still wonder about this or have heard arguments to the contrary to which you'd like to respond, please refer to the Logical Science website for documentation of the consensus. I will leave this website also at the end of the reading. Students are also encouraged to browse the information on these additional website links, to which are provided at the end of the chapter: National Snow and Ice Center, World Wildlife Fund, Real Climate, and World View of Global Warming. So what is the scientific consensus? The sun's energy enters the Earth's atmosphere and heats up the planet, after which much of it's radiated back into space in the form of infrared waves. Under normal conditions, some of those waves are trapped by the atmosphere, thereby helping keep the Earth's temperature within a habitable range. However, the accumulation of carbon dioxide, CO2, and other greenhouse gases has led to more and more of the infrared radiation being trapped within the atmosphere, thereby increasing the temperature of the atmosphere and ultimately the Earth itself. Human activities have contributed to the increased concentration of greenhouse gases since our prehistoric ancestors first began significant deforestation thousands of years ago. Redmond, 2003. However, the rate of increased accelerated greatly after the onset of the industrial age because recent growth has been powered by the burning fossil fuels. The level of CO2 in the atmosphere is currently about 412 per million ppm. National Oceanic and Atmospheric Administration, NOAA, 2021. This concentration is higher than at any time in the past 3.6 million years. It is higher than at any time since the evolution, Australopithecines, and higher than anything that has been experienced by modern humans as a species. It is estimated that if current warming trends continue, the level of atmospheric CO2 could reach 500 to 600 ppm over the next 45 years. These numbers, these facts, and estimates should be a matter of great interest to anyone who cares about the continued health and viability of our species and other organisms with which we share the planet. Denial is not just a river in Egypt. There is very little doubt among climate change researchers that global warming is really happening and human actions are contributing significantly to the results. Yes, it is politically and socially controversial allegation, but the science is not in doubt. Donald Kennedy, editor of Science magazine, the journal of the American Association for the Advancement of Science, has remarked the consensus as strong as the American Association for Advancement of Science has remarked that the consensus as strong as the one that has grown around this topic is rare in science, 2001. James Baker, former head of the National Oceanic and Atmospheric Administration, NOAA, said there is better scientific consensus on this issue than any other. With the possible exception of Newton's law of dynamics, there is always debate in science. So it is true to say there is still debate about the climate change. However, the debate has long since moved beyond whether global warming is happening and whether human actions are contributing to topics such as how the details are playing out, their implications for specific regions, and what we might try to do in response. The operation of elements that work together to produce weather and climate are complicated, and more research needs to be done. But that doesn't mean we should withhold acceptance of or a response to the large-scale changes that can already be documented. In 2006, Dr. Charles Kennel made a presentation as part of the University of Texas at El Paso Millennium Lecture Series entitled "Had We Whirled Enough in Time? Global Earth Science and Sustainability." Dr. Kennel is director of the Environment and Sustainability Initiative at University of California, San Diego, and former director of the Scripps Institution of Oceanography, where the accumulation of greenhouse gases was first discovered 50 years ago. He oversees the program that has sensors placed in the oceans all over the world to monitor temperature changes. For him and his staff, the question is not whether climate change is happening or whether human actions are contributing. Those issues have been clearly laid to rest. They are now focused on refining and understanding of the details of the changes so that we can minimize the loss of life and property. And, in the most vulnerable regions, Kennel estimates that we have until about 2055 to figure out a global response. If we are to prevent truly catastrophic losses, continued debate over whether global warming is happening or whether humans are to blame will cost many lives. A fair analogy would be this: global warming is in doubt only the same way that evolution is in doubt. That is, there is no scientific debate about whether evolution is real. Although there is a debate about how it happened in specific cases, like reality of global warming, the fact of evolution is controversial, but not because the science is in doubt. It is controversial because the science has implications for people's social, ideological, and economic beliefs and programs. Researchers and teachers who deal with the topic of evolution have been subjected to social or opposed to scientific skepticism and Darwinism for years. We recognize the political rhetoric and forms of argument used to fight evolution that are now being used to deny global warming, such as denying the science, mounting ad hominem attacks against scientists, and enlisting political operatives to make policy changes that aren't supported by the science. The uproar over climate change research has reached the public's awareness more recently. So the reaction of non-scientists is still cresting, contributing to the perception of great uncertainty where there is little or none evidence of climate change. The science behind global warming is not new, and the findings are not controversial for most climate researchers. Why? Because the data have been accumulated for decades, and scientists conducting research in this area have been watching the patterns in the data become clearer by the decade. When I was in graduate school in the 1970s, I studied climate change. I took a graduate minor in geology, specifically glacial geology and climate change. Archaeology figures into this area of study because archaeological sites provide evidence of both natural changes and human effects on the environment, such as regional vegetation change and ways of dating the changes documented in these sites. One of my professors was using prehistoric pollen data to reconstruct changes in the locations of winter and summer air masses during and after the late Pleistocene, and the effect of those changes on the makeup and distribution of vegetation communities. Of course, back then the research wasn't playing into a public discourse on global warming. It was below the public's radar, so to speak. But the point is, when scientists say that they can distinguish natural cycles of climate change from human-induced changes, they have the data to back it up. They've been studying both for more than 40 years, whether the public was aware of their efforts or not. A couple of years ago, a good friend asked me with some indignation and disbelief how scientists could know that global warming has even occurred. As a devote of Rush Limbaugh, he was under the impression that scientists are making irrational, political motivated guesses based on the past 50 years or so of weather records. He asked, "Do you have some sort of prehistoric thermometers out there that you dig up?" Well, actually, yes, we do. At least indirect indices of temperature. Researchers have been analyzing glaciers, ice cores, tree rings, varves, silt layers in northern lakes, prehistoric pollen profiles, prehistoric faunal assemblages, seafloor sediments, and the contents of prehistoric pack rat nests for years. The patterns in all these sorts of data indicate that global warming is real and that human actions are contributing significantly to the observed changes. Now you see it, now you don't. The amplitude of cyclic changes can be attributed to natural causes has been well documented. So it is possible to identify the human contribution to current CO2 levels. See figure 11.1 in chapter 11. The fluctuation of atmospheric CO2 is clearly indicated in ice cores drilled in Greenland and Antarctica. The Antarctic cores go back 650,000 years. One can count the individual layers of ice down each year, actually see the increase of airborne particles resulting from the industrial age, and measure the chemical composition of the atmospheric and air bubbles trapped in the ice. At the time each layer was deposited, the major periods of glacial growth are indicated in blue, and the intervening warming periods are in yellow. In past Pleistocene warming cycles, CO2 levels have only once risen above 290 ppm during the Middle Yarmouth interstadial about 325,000 years ago, and have never exceeded 300 ppm. We are presently in another warming cycle, the Holocene, but human activity has caused the CO2 concentration to overshoot the natural levels of previous warming cycles. Current levels of the atmospheric CO2 stand about 412 ppm, higher than at any time in the past 3.6 million years. The last time CO2 levels were this high, the Earth was inhabited by Australopithecus. Here's the graph, by the way. There are some, perhaps many, citizens and surely several right-wing pundits who reject this information out of hand. It is Al Gore or some university scientist who are presenting the information to the public, but a rejection of the evidence for that reason is illogical. An example of argumentum ad hominem: one must evaluate the data rather than dismiss the messenger. And these data are solid. But if data are solid, then why do so many citizens and even a few scientists still reject the argument of climate change? Some reject the data because the implications challenge what they believe they know or what a trusted pundit has said, or because they run counter to their hopes for our country's policies. There seem to be several types of people or several kinds of groups sharing certain sorts of attitudes or interests who, intentionally or not, are contributing to the confusion. They include people who just don't understand science, those who are ideologically opposed to science in general or global warming in particular, those skeptical of the idea that humans can alter the earth, and those who continue benefit economically, politically, etc. By maintaining the status quo, let's consider some examples. As scientists, we shouldn't expect the policy to simply trust us because we know what we're doing, but the public has or should have some responsibility to make an effort to become aware of and understand the scientific information. Herein lays one of the main difficulties in discussing the issue of global warming. Our society is largely poorly informed about climate science, and the public has not followed the research that provides the evidence for warming. Therefore, the general public is dependent on journalists, elected officials, and the media to inform them about and explain the findings of science. Unfortunately, surveys have shown that our politicians, political pundits, and newspaper editors, among others, are usually no more knowledgeable about science than other members of the public. Yet they have far greater access to the public than do scientists. As a result, much of the information on warming that does reach the public is misrepresented, screened, censored, distorted, and misunderstood. It is no wonder that the public is confused. Bias is contributing to climate change denial. Although climate change denial is not necessarily limited to one particular party or another, some analysts suggest that political ideology does indeed influence the way the warming issue is presented and discussed. The results of polls conducted by the National Journal indicate that although evidence for global warming has been getting stronger, many conservatives have become increasingly skeptical. In other words, skepticism about global warming is becoming political party dogma. It is not clear why this should be the case. Even much of the energy industry has accepted the reality of warming, with some executives asking for increased federal regulations of their own industries. Chpt 2007 suggests that conservative movement seems to be taking its marching orders on this issue from a very small group of ideological leaders who have decided to defy the scientific consensus. The phenomena here is that a tiny number of influential conservative figures set the party line, dissenters are marginalized, and the rank and file goes along with it. A fairly well-known example involves Limbaugh's derisive comments diminishing the reality of global warming. He said even if polar ice caps melted, there would be no rise in ocean levels. After all, if you have a glass of water with ice cubes in it, as the ice melts, it simply turns to liquid and the water level in the glass remains the same. Rendell et al., 1995, 17. Unfortunately, Limbaugh's analogy is inaccurate and faulty. Most of the ice in the world is not land, not already, floating in the oceans the way ice cubes are and floating in his drink. When the ice melts, it does not contribute to ocean level rise. A fact that is already being recorded. I encounter questions every year from students, often quoting their parents who have been misled by Limbaugh's statement. He and other pundits like him have done enormous damage to the public's understanding of the issue in service to whatever ideological position he thinks will benefit from the confusion: anti-liberal, anti-environmentalist, anti-United Nations, anti-foreign aid, anti-alternative fuels, or whatever. Another sort of ideological bias or vested self-interest is evidenced in the censoring of government scientists by political appointees. One of the most recent administration officials whose actions are most egregious in terms of misrepresenting science was Philip Cooney. Cooney was an American Petroleum Institute lobbyist who was hired as a chief of staff in the White House Environmental Office during the second Bush administration. Even though he had no scientific training, he was authorized by the White House to edit, revise, and censor scientific reports on global warming written by scientists in various government agencies. He would probably have continued doing so for several years if a principled whistleblower had not exposed his intellectual fraud. Cooney resigned and was quickly hired by ExxonMobil. It is not hard to understand that he had personal, ideological, and financial reasons for resisting and misrepresenting the scientific evidence for global warming. He is only one of many administration officials who have viewed one of their tasks as denying, censoring, and undermining legitimate scientific findings that would otherwise be communicated more clearly and honestly to the American public. In some agencies, nearly half of the staff scientists have reported experience censorship or pressure to alter their findings from their politically appointed supervisors. Public employees for environmental responsibility. In recent years, some administration officials have completely removed any mention of climate change from several government agency websites that were formerly used to inform the public about the issue. False balance in the media. The media are also partly to blame for their ignorance of how science works, for oversimplifying concepts to the points of misrepresenting them, and for sometimes misguided attempts to create balance in their coverage of science topics. Even the way a topic is framed can influence the discussion. For example, the media have often presented global warming as if the entire Earth is warming in a uniform way. And when people see evidence to the contrary, they become confused or doubtful. But the scientific understanding of global warming doesn't say this. Scientists recognize that heating is not uniform. On all parts of the globe, it is recognized that some parts of the Earth might seem to be cooling slightly and others heating as global air and ocean circulation patterns change. So climate change deniers who point to regional details such as increased rain in northern Europe or increased snow in eastern Antarctica, for example, have been misled. The recent global warming models have predicted these sorts of regional variations. It is also sometimes the case that earlier scientific findings have been revised or corrected by more recent research, but the earlier findings are still promoted by the media. For example, one paper from the past decades suggested that high-altitude balloon data indicated atmospheric cooling instead of warming. Since then, those data have been re-examined, and it has been determined that the sensors used to gather the data didn't function properly when the original study was conducted. Newer data have overturned the older study, thereby supporting the warming predictions. But some of the media and climate change deniers continue to cite the older paper as legitimate counter evidence. That simply is not an accurate representation of the state of the science. Another common problem is the media's effort to report or even create balance in the news, even when there isn't. If 98% of the scientists in the world would accept the evidence for evolution and 2% do not, then giving equal time to both positions is not balanced. The same goes for global warming. Imagine if a reporter at a house fire worked very hard to find a view that would balance the news of the shock, disorientation, and sorrow of the homeless family. Would we applaud the effort to find anyone? We thought the fire was a good thing. Perhaps a neighbor who observes that at least they won't have to paint the gutters this year. Wouldn't that strike you as trivial or misguided? But that's something NASA's Dr. James Hansen has testified about global warming at congressional hearing and in apparent attempt to provide balance. The reporter finds anyone who might be willing to rebuke Dr. Hansen. When the reporter can't readily find a scientist willing to do so, because there are so few. He gets a statement from Oklahoma Senator Jim Inhofe, who has no scientific training whatsoever, earned his college degree in economics and represents an oil-producing region. Senator Inhofe steadfastly refuses to even consider any of the scientific evidence placed before him, and considers global warming a hoax. He is certainly entitled to his opinion, but why should that opinion be represented as equivalent to Dr. Hans's warranted argument based on scientific evidence? That is not balance in any meaningful sense of the word. The media can sometimes be cavalier about how they represent and compare the various groups who comment on the topic of global warming. The Intergovernmental Panel on Climate Change, IPCC, is a case in point. Created in 1988 under the auspices of United Nations, the IPCC is not just another organization with an opinion paper. Rather, it is a clearinghouse that reviews, evaluates, and summarizes the work of climate scientists from all over the world. The IPCC reports themselves are then subjected to scientific review. Only the most widely accepted and therefore perhaps the most conservative conclusions are included in the final reports. The counter-arguments denying warming issued by political policy groups are not comparable to the IPCC reports because they aren't based on the sort of comprehensive examination of the science that is undertaken by the IPCC. And the policy statements they produce are not peer-reviewed, therefore they should not be interpreted as providing balance to the positions articulated by the IPCC. Additional evidence of the impact of balance in the popular media is provided by a study of peer-reviewed science articles on global warming from the past decades. Ipcc 2004, a scientifically selected 10% sample of articles, N equals 928, was drawn, and the articles were analyzed in details for their findings on the issues of climate change uncertainty. The articles were unanimous in their conclusions. The percentage of similar analysis of the global warming stories published in the 4 major U.S. print media, New York Times, Los Angeles Times, Wall Street Journal, and Washington Post, found that 53% of the popular articles expressed doubt about the human's role in warming. More than half the articles gave equal weight to the scientifically discredited notion that humans play no role in warming. Clearly, some of the most influential media outlets in the country have been complicit in grossly misrepresenting the science of global warming to their readers. There is very little scientific debate about the overall facts of global warming, but this reality has not been clearly communicated to the public. There are admittedly a few scientists who continue to argue against global warming, or at least against a significant role for human agency, just as there are a few scientists who continue to argue against evolution. But just because some scientists are climate change skeptics doesn't mean their skepticism is still warranted. A decade or two ago, such a position might have been considered cautious or even prudent. Today, it might be considered irresponsible. There are several reasons scientists might continue to deny the evidence for global warming. One might be that they don't conduct research on the subject and have not stayed abreast of the recent literature. Another might be a paradigmatic, I'm sorry if I mispronounced that, belief that humans are not capable of causing large-scale effects on the Earth or atmosphere. Such an assumption has sometimes been evident in the interpretation of archaeological remains in the Southwest. For example, it has long been known that the Chaco Canyon and Mesa Verde were heavily occupied by prehistoric peoples for a time, but that both areas were abandoned, perhaps abruptly. For a long time, many researchers were convinced that climate change caused the region to become uninhabitable, at least for Pueblo agriculturalist, leading to the abandonment. This view was based on data for vegetation change, mainly from pollen studies, which seems to indicate the loss of pine trees. However, when scientists began comparing prehistoric pack rat nests against the pollen data, a different picture emerged. Pack rats, Neotoma, collect local vegetation with which to build their nests. The animals urinate in the nest, thereby fusing and preserving them, and defecate in them, leaving behind pellets that can be dated by radiocarbon. The nests are effectively time capsules containing samples of the local vegetation. The pack rat nests in Chaco Canyon showed that only the incidence of trees changed, not overall vegetation in the vicinity of the nest. The new data showed that the loss of pine trees was not the result of climate change, but of deforestation by prehistoric Puebloan peoples. Human-induced environmental degradation contributed to the changes that forced the people to relocate. It hadn't occurred to many researchers that prehistoric populations could actually alter the environment to the extent scientists trained or influenced prehistoric populations could actually alter the environment to that extent. Scientists trained in or influenced by such paradigmatic expectations may well be honestly predisposed against the evidence for phenomena that seem to be beyond the scale of human impacts. Hopefully, such a predisposition would eventually be overcome by paradigm shift in response to new data. There is another more troubling reason some scientists might still maintain a position not supported by the evidence. Money. There has been an organized effort on the part of companies in the extractive industries to sow doubt about global warming in order to confuse the public and derail action by legislators. Begley, 2007. Among other revelations, a conservative think tank funded by ExxonMobil offered scientists $10,000 to write articles undercutting global warming science and climate models. One scientist even admitted receiving $165,000 from the coal industry to trash mainstream environmental science. This is not how academic articles are normally written or how the academic publication process operates. The tactics of think tanks, public relation firms, and lobbying groups involved in the organized denial of climate change are modeled after the tactics used by the tobacco industry in their denials about the harmful effects of cigarette smoking. Unfortunately, the well-funded lobbying efforts have successfully misled much of the public about the scientific consensus on warming. Most scientists are not policy wonks. Most are nose to the grindstone researchers. Yes, some are occasionally thrust into the policy limelight because of implications of their research, but most do not have an axe to grind with regard to public policy. They're just doing their work on bugs, worms, sedimentation rates, tree ring width, animal migrations, bark beetle infestation, sunspot activities, Arctic shoreline erosion, coral bleaching, etc. They are usually not trying to attack certain people, agencies, administrations, or programs. Scientists are just trying to make the best sense they can of the natural phenomena they observe in the world around us. Mostly scientists just do science. And as is the case with evolution, just because the scientific results are unsettling or inscrutable to some members to the public doesn't mean the results are false or uncertain. Evidence and decision making. In his book, Collapse, How Societies Choose to Fail or Succeed, Jared Diamond, 2005, explores how and why some societies were unable to make sense or take the actions that would have ensured their survival. One of the cases he considers is the fate of the Aboriginal inhabitants of Easter Island. He wonders about the thought process of the person who chopped down the last tree on the land, thereby completing the destruction of the ecosystem to which the islander society was adapted. Perhaps we should consider an analogous circumstance that may be faced by our own society. Who will be the one who watches the last mountain glacier melt? And what would they be thinking about that? Is it really possible that enough humans can be blind to the evidence, the effects of climate change, that we can actually stand by while the natural systems that support our societies are altered beyond recognition? How many of you know someone who has never viewed an inconvenient truth or an inconvenient sequel? Why haven't people gone to see them? Have they ignored the documentaries because some political pundit or television personality disapproves of them? Why do we as individuals choose to remain ignorant of or unresponsive to the evidence for climate change? Why do we choose to let others do our thinking for us? Sam Gudrazi, writing for Live Science, 2007, reports on a talk given by John Krosnak, professor of communication and political science at Stanford University, in which he addresses the disconnect between what science knows and what the public believes. Krosnak said that in order for the public to embrace an issue like global warming and make behavioral changes, they must believe that the problem exists and that the results would be bad for people. Because the public doesn't have absolute certainty about the problem or certainty about human agency, warming doesn't generate the same sort of concern that scientists have expressed. Furthermore, Krosnak suggested that most people won't acknowledge something that is a problem unless they believe it can be fixed. If they believe it can't be fixed, it is simply too upsetting to think about. So the efforts by climate change deniers who suggest there is significant disagreement among scientists are contributing directly to the public's lack of sense of urgency and will be addressing the problems. Nevertheless, evidence of climate change is all around us and becoming more obvious with every passing year. The Arctic is warming faster than other parts of the globe, and more than 200 native Inuit and Aleut villages are threatened by climate-related erosion and or flooding. 31 communities are facing immediate threats of destruction and will need to be abandoned or moved. U.S. Government Accountability Office of 2009. Glacier National Park in Montana has lost almost all of its ice, and the remaining glaciers will probably be lost over the next few decades. The snows on Kilimanjaro in Africa survived a 300-year period of drought that occurred about 4,200 years ago. But today's climate change is different. If current climate conditions persist, the Kilimanjaro's ice fields will probably be gone in the next several decades. Thompson, ETL, 2009. Key indicators of Arctic climate change, 1971 to 2017. I will close in on this so that you guys can watch that. I'm sorry. The most potentially damaging loss of mountain glaciers is in the Himalayas. When the 50th anniversary celebration of the first summiting of Mount Everest was held a few years ago, The ceremony was held at the site of Edmund Hillary's and Tenzing Norgay's base camp. At the time of their climb, it was at the base of the Khumbu Glacier. Today, the campsite is 5 kilometers from the base of the glacier. The Khumbu Glacier has melted and receded that much in the past 50 years. The real scary part is 7 major river systems originate in and are fed by the Himalayan glaciers. They provide half of the drinking water for 40% of the world's population in parts of China, India, and Southeast Asia. Increased melting will cause flooding in the short term and over the long term. That fresh water will no longer be held in storage for human consumption. The efforts of climate change are already being felt in terms of human agricultural production. Warming over the past 25 years has led to decreased yields from some of our nation's most important food crops: wheat, rice, corn, soybeans, sorghum, and barley. Researchers found that decreased yields and increased use of chemical fertilizers and pesticides coincided with periods of increasing temperatures. These crops account for more than 40% of the production of the world's farmlands, 55% in the non-meat calories we produce, and more than 79% of the animal feed raised worldwide. It is predicted that if global warming continues along its present trajectory, sea level will continue to rise. The conservative estimates speak about something in the range of 3 feet in the next 50 years. More extreme possibilities include an eventual rise in sea level of 18 to 20 feet. If all of the mountain glaciers and most of the Greenland and Antarctic ice fields melt, a 20-foot rise in the sea level would displace hundreds of millions of people, especially in low-lying coastal areas of Asia, such as Beijing, 20 million, Shanghai, 40 million, and Calcutta, and Bangladesh, 60 million. It is uncertain whether the number of tropical storms will rise, but it is predicted that their intensity will increase because the intensity of the storms is fed largely by the surface water temperature. The slightly warmer surface temperature in the Gulf of Mexico is why Katrina grew from a Category 1 storm on Florida's east coast to a Category 4. By the time it hit New Orleans, coastal population will be increasingly vulnerable to high-intensity storms. We are likely to see more fires like the ones that ravaged Europe in 2003. Lowland insects such as mosquitoes, ticks, and siteflies are migrating to higher elevations in latitude, carrying diseases to populations of people who have never experienced them before. Forests are being decimated by bark beetles whose spread is no longer contained by cold winter temperature. Areas that are expected to experience reduced rainfall and worse droughts include most of the southwestern United States, the southwest coast of South America, sub-Saharan Africa, much of China and Southeast Asia, and central Russia. Much of North America and northern Europe is predicted to receive more rainfall but less snow. Parts of southern Australia are already being abandoned by farmers because of the extended drought conditions. If these sort of effects are not enough to inspire action from the public, one wonders what it will take. Here's this. Denial continues to be something more than a river in Egypt. Denial is widespread here in Texas. We are asked not to litter, don't mess with Texas, but we're happy to pollute. Texas emits more CO2 than any other state in the country. If Texas were a country, its emissions would make it the 7th largest CO2 polluter in the world. Burnett, 2007. The state's high level of emissions is mainly a result of large coal-fired power plants and large base gas guzzling vehicles. 35 other states have plans in place to cut CO2 emissions, but many Texas leaders are global warming skeptics. State Senator Kirk Watson from Austin proposed a bill that would have created a task force to study the effects of climate change in the state. It passed the Senate, but died in the House, where it was opposed by lobbyists representing the oil, gas, and coal and chemical industries and state automobile dealers. When Reverend Raymond Bailey asked his Waco congregation to consider by reducing the trips they make in their cars, they told him, "Now, preacher, don't mess with our cars." Burnett, 2007. The choice between our fossil fuel-powered cars or the health of the planet should not be a tough call. The last time CO2 and temperature conditions on the planet were anything like today, during the Riswarm interglacial, there weren't anywhere near as many people on the earth, perhaps fewer than 100 million, and none of them lived in cities. All of them were mobile foragers or hunter-gatherers, capable of moving at a moment's notice without significant loss of lives or property. Wherever they moved to, the land was likely to be vacant or only sparsely occupied when they arrived. The Western Hemisphere was completely devoid of people. The concept of land ownership didn't even exist. Think about how different our situation is today and how much more disruptive large population movements will be. Recall the problems associated with relocating and caring for 500,000 Katrina victims, the 2.5 million refugees of the Iraq War, or the tsunami victims in Southeast Asia, and multiplying those scenarios by a couple of orders of magnitude. More than half the population of the planet live among the coasts. In 1990, that amounted to about 3.6 million people. It is estimated that by 2025, that number will be 5.3 billion. When will we be ready to face the scientific evidence? When will we be ready to make behavioral changes in response to climate change dangers? What form will those changes take? What will be the outcome of the nature's evolutionary experiment, the one we call humanity? This is the end of chapter 14. Thank you.